Attendees are in listen-only mode.
Okay, everybody, howdy. It's 9 right now, but I think we're going to give it a couple of minutes and let the stragglers come in. So I will start back up in a couple of minutes. Until then, enjoy the first slide. Okay, everybody, it's me, it's Brian. For all of you that don't know me, my name is Brian Schwab. I've been in the industry for 20 some odd years. I've worked all over the place, DreamWorks, Sony, Blizzard, the Collective, a whole slew of different companies, a whole slew of different products. I've shipped 19 titles. My last one was Hearthstone for Blizzard Entertainment. I'm currently working at a small startup who are being contracted by Sony Online Entertainment to do the AI for EQ Next as well as Landmark. So here we go. The talk today is called Emerging Concerns, and basically I want to talk a little bit about procedural AI and some of the issues with it and how to get around some of them. So anyways. So AI in general is very expensive. A lot of game companies treat it as like this nasty sort of thing that they have to do, but they don't necessarily want to do it. It takes a really long time to implement, and the staff that does implement it is usually pretty expensive. It's a highly technical sort of craft. It takes a lot of time to test it and debug it. It can essentially be an unbounded amount of time to test it and debug it based on how it's implemented and the system itself. It takes a long time to maintain. If things are going to get added into the game, it could throw stuff out of balance. There might be an extensive tool chain involved if it's data-driven AI and there's a design staff that's being authoring a lot of things. So it's not potentially just the game that you're testing and debugging and maintaining. It's several tools. So that can be an expensive addition as well. And plus, a lot of games nowadays don't even know how many people are playing the AI versus multiplayer. This kind of comes and goes with AI over the years. Like when I first started, all games were essentially single-player games. Even games that were primarily thought of as multiplayer, like say sports titles, we did some market research in the as late as 2005 and found that 70–80% of all of the people that were playing our game were playing it single player. And this was a sports title that's specifically made for 4 joysticks to hook up to your PlayStation and play. So, a long time ago it used to be AI was super important and you had to have single player because that's how your game was played. And then slowly over time we've had a rise in multiplayer, like online gaming is pretty huge, and then you have like the mobile platform, which is basically almost assumed to be online ready, if you will, and so a lot of games will forego a lot of these expenses of AI in order to do just multiplayer games. And now we're starting to see a resurgence of AI because people are starting to realize a couple of things. I think that multiplayer games can sometimes be a little bit of a double-edged sword in that, yes, you get a good opponent, but you also get, people being toxic to each other, as well as the games are complex enough that you need AI opponents to beat on in order to even learn. And so how big the audience is for single-player games is typically in flux, but it is a question, and it is something that large companies take into account when they're figuring out how expensive the system really is as far as their budget. So procedural AI systems can sometimes help with this because it's not super crafted out as far as, one of the super expensive parts about AI is the handcrafting, is the length of time to implement and that kind of thing. And so if you go for more of a systems AI approach, obviously you can curb a lot of those concerns, but you get a new set of concerns, right? And so some of the concerns with I believe, by the way, I'm calling it procedural AI instead of emergent AI because I think emergent is kind of a nasty word. It to a certain extent puts forth that the people that are making the AI system don't have any idea what's going to happen. And while the certain combinations of things that come out might be surprising or might be new in some ways, I think that word is loaded, and procedural is a little bit better word in that what it implies is that the system behaves with a set of rules as opposed to being hand scripted, and so that's kind of why I'm calling it this way. So one of the big concerns is that the procedural AI requires an entirely different authoring suite, if you will. You really have to abstract out what you're doing an extra level deep. In fact, that's kind of the whole point of a procedural AI system, is that you abstract one level deeper. And also, procedural AI can be very difficult to sell to designers because they might feel like they're losing a little bit of control. I've given several talks on this, and we can cover this a little bit later. And the next big sort of concern is that systems can feel kind of generic. They can feel like you're giving a procedural answer for any given question, and that can be the case, right? I mean, this is something you have to watch out for when you're doing this, and because you have an underlying procedural system, if you do have a systemic exploit, obviously the entire game can be infected with it, so it's something you need to worry about. And lastly, when you have a system that is potentially unbounded as far as like what it can respond to and how it can respond, you have definite QA risks. So there might be the inability to ensure total lockdown, if you will. So QA departments get a little bit flippy when you start talking about procedural systems or emergent gameplay in any way. So I kind of want to go through these and answer these things one by one. So first, the authoring sort of stuff. I've given some talks on this at GDC. I think that AI has gotten a little bit too separatist. It used to be that AI and design were the same guy, right? We didn't really have huge staffs of people that were super specialists. And then over the years, it has really gotten that way, where we have AI programmers and we have game designers, and they've very much separated. However, really good AI programming, really good AI creation is a huge design task. It to do AI well, you have to really think about the player experience and think about game decisions. It's not something that should be as separated as it is, and I think that reintegration of the two camps really needs to happen. And so I think that saying, oh, this procedural systems require an entirely new authoring style is fine, because we really need to start getting used to new authoring styles, because reintegration of these two camps needs to happen in order to make our games that much better. Secondly, when the players have a lot more freedom to do things, a lot more space to do things, they're much less. Oh, excuse me. I got ahead of myself. You don't have to sell these systems to the designers as much if they themselves have more power. If the designer can, if you can educate the designer that you're not trying to usurp his control, but rather to enhance his control, to enhance his leverage, to change things in the game and to make the world sort of a living system as opposed to just stepping through a script that he's made, it kind of sells itself. Once the designer starts to feel the power that they are being given, it really isn't as hard as you'd think to sell this to designers. Now, if you have an entrenched design staff that have been doing things for a zillion years, I mean, I ran into this a bit at Blizzard, because I mean, those are some of the the most talented designers out there, and they've been doing hand-polished work for decades, really. And so I definitely ran into a little bit of resistance there. But I mean, even at Blizzard, I was definitely getting some good traction with people seeing the benefits of giving up a tiny bit of what's the word? A tiny bit of direct control for massive leverage. One good designer can generate orders of magnitude more content in the same time by using procedural systems that they're guiding. And that's my other point. It becomes an education to show them, like, hey, you're not giving up control. I usually use what I call the animation metaphor, which is, I talk about how in the old days, animators used to draw every frame. You watch a film like Snow White and the Seven Dwarfs, and some team of guys drew every single frame of that movie, from soup to nuts, and they were super talented guys, and it took years of their time in order to do that. Whereas nowadays, the really high-end animators just do keyframes, and the middle frames are either done by keyframe houses in somewhere else, or they're done by computer. They're tweened by computer, and those middle between frames are not considered a loss of animation power. They're considered busy work. And hopefully down the road, when we see more of these procedural content systems being used by designers, they can see that they're not losing control, but yet they're not having to do sort of this tweening work of AI. They get to do the powerful keyframe work of AI that's really the stuff that they care about anyway. And on that same route, I like another art metaphor to sort of describe why procedural systems are important in moving forward in the AI world and in games in general. And that is, artists used to draw characters, and they used to draw their actions directly, right? I mean, we were talking, sprites or whatever, where they're fully drawing the entire thing, and when they go to animate it, they fully draw out the entire animation. Whereas nowadays, they three-dimensionally model the character. So the character physically is modeled in the game, or you know, in a modeling program, and now every time they go to make an animation, they just animate that model. They don't have to redraw the character over and over and over again from all different directions. They now have a reusable chunk of art that they can then repurpose going forward. And likewise, we've been kind of hand drawing NPC actions. We've been effectively using AI sprites, if you will, and we hand draw the animations, we hand do the characters, and I think personally we need to move forward and actually model our NPCs so that we can use some procedural systems to determine the actions. I mean, we still end up having to do the actions themselves, but the mappings and all of those things can be done in a more reusable way, in a more abstract way, so that we don't have to do everything by hand. And we finally might be able to actually reuse some AI. I mean, imagine you have a suite of NPCs that you've modeled out, and being able to cast your next game from those guys instead of having to start from scratch and go from there. But the metaphor from the art world also shows the cons, right? I mean, there's a lot more data. When you have an animation, or you know, like an animation of a character in sprite data, it's just that. It's just the size of the image times the number of frames. Whereas when you model a character, it's the model data, it's the texture data, it's the light map data, it's the bump map data, it's the shaders, it's the la 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 la, and therefore, just like in the art world, an NPC model is much more highly technical to implement. You have to kind of, there's a lot of data that's very specific and very technically sort of advanced. And development is more front-loaded. You are building these models up front, and then you're using them going forward. So there's a lot more cost up front. There's a lot less forward movement at the start of the project. You have to kind of like know that you're going to get a lot out of it after the first thing is built. So the next big concern is the generic feel one, and this is a big one, right? Because when you handcraft things, you can get very specific about how you want the experience to be and how you want the player to interact with things. Whereas when you have a procedural system, it's more like a sandbox. It's more like, let's say, The Sims, where yeah, things are highly polished, but the day-to-day, the second-to-second interaction between the player and the game is very largely determined by the player as opposed to the designer. And if you don't watch it, you know, if you don't have a large enough bucket of rules and a nice little sandbox for the people to play in, it can feel generic. It can feel like they don't have enough space to move around in, and it can feel like all the interactions are a little bit the same. So, you know, the procedural systems are always going to have limits. You know, I mean, unless your game is like, let's say, Angry Birds, where the thing you're modeling is physics, right? It is procedural. So it does pretty well, right? I mean, this is a bad example because there is no AI in Angry Birds, but you see what I'm getting at. If the pigs were flinging things back at you, it wouldn't be very difficult. It wouldn't seem weird because the thing that you're dealing with is procedural. So the other thing that, because you're building a procedural system, don't rely on the algorithmic rules to determine everything. There's always going to be exceptions. You're always going to have special cases that come up that the designers really require, or that the game itself really requires, in order to be fun or to be whatever. And so in answering the generic feel sort of concern, make sure you build exception handling into the system. You should be able to add special cases fairly easily and at not a heavy cost. So it's not like, well, we can add it, but it's going to throw us really into a spin. One of the big ones was in Hearthstone. It was a very, very algorithmic system. As a card game, the vast majority of the game is done in rules, right? However, because of the fact that Blizzard requires a heavy amount of polish, at any given point, if the designers really said, hey, you know what, this particular rule, we need to break this rule, even though it doesn't quite fit into the paradigm of how we've laid out the rules. It just feels better, and it's more quote-unquote intuitive to the user if this particular rule happens first, even though that's not following the norm. That definitely happened from time to time. And I mean, on the project that I'm working on now, that's very much going to be the case. Landmark and EQ Next are very, very sold on procedural AI and having their game worlds be very alive and very sort of moving without you, if you will. However, they also want what they call game events, which, in the middle of everything, in the middle of the day, something big might happen, and bang, the AI has to deal with it. They're going to spawn a giant happening right in the middle of everybody just because it feels great when that happens in MMOs. And the AI needs to be able to handle that. It needs to be able to handle exceptions in a first order sort of fashion. So the other way, the way that you really get around this, the way that you really get around the generic feel of the game is that you basically make your NPCs act as a layer of abstraction to the game. So you make your NPCs and your players act towards abstract resources as opposed to direct game resources. And the reason that this helps is that now anything that provides those abstract resources end up working out for the player. It allows you to mix and match and add and do all sorts of things on the fly as well as tweak things on the fly, and the AI isn't going to suddenly break. They're working towards this layer of abstraction instead of direct resources in the game, and what that gives you is the ability to it gives the game the ability to mix and match at a much higher sort of level than direct, authored content can do. And what am I talking about when I'm saying NPC modeling and that kind of thing? I'm talking about building a mental model of the NPC instead of just the physical abilities that it has. You're abstracting out sort of like the NPC's mind, the ways in which it's acting based on some form of driving model of his cognition. Some of the axes of this model can be purely mental, like an ocean behavior personality model, but it could also be just levels of relationship with other entities in the game, or just weirdly abstract things that are very game dependent, like, does this person never give up, or is he completely devoted to a particular other entity in the game? And when I say NPCs, remember that I mean individuals as well as organizations, or an NPC doesn't have to be a particular person that you talk to. It could be the Wizard Guild, or it could be a completely abstract entity that's just used for Overwatch on a particular battle scene or something like that. But by making NPCs with a mental model, with intent, with desires, with beliefs, instead of direct behaviors and the things that trigger those behaviors, you get that level of indirection that I was talking about. So then when you hook up those intense desires and beliefs to the end behaviors and the triggers, you sort of get the same feel that you would have if you were hooking them up directly, but you have that layer of indirection. So now if I add additional behaviors to the game, as long as they service a particular desire or intent, they'll work. They'll incorporate this new behavior. If you make new objects in the game that could potentially give NPCs what they want, they'll incorporate the new objects into the game. If you change the rules, they'll stop doing the things they used to do that they're following the old rules, and they'll follow the new rules, and you by having that layer of abstraction, you stop the breakage of that direct link between end result and the NPCs themselves and the rule set. You allow a lot more sort of flexibility into the system so that you can add things, subtract things, and the AI won't break. And that's why, kind of like a good DM, I don't know if any of you watched Luke's talk last month on being a good DM or whatever. The NPC's goal should be flexible, and that the people in places can kind of be changed out by the game. So if something happens and somebody kills somebody that you didn't expect, somebody else can be swapped into that spot as far as this particular storyline is concerned, and you can keep going just like a good DM. Now, you need that level of indirection in order to do that, because otherwise things are sort of hand scripted in place, whereas if roles are kind of determined when they need to be determined, and if they need to be redetermined, that's possible, and that kind of thing. This is what a good DM does, right? He sees that the story is being sidetracked and kind of gets us back on track, as well as recognizes that that guy died and I need to use his brother instead now, and so that kind of thing. The great thing about it is that then when you try to go to do player modeling, you can actually use the same NPC model. You can use the same system that you're using to model your computer-controlled characters in your game or entities to start the process of learning more about your players. I think there has been some work over the years with games on using player modeling to do dynamic difficulty adjustment, and I think that there's issues with that. A lot of games will like go, oh, you're beating everybody, so we're going to make everybody more difficult, and you have sort of a rubber banding effect on the difficulty of the game, and all that really tends to do is make people figure out what the system is adjusting, and just sort of play down their playing, dumb down their playing a little bit so that the game doesn't do it. They have essentially exploit the rubber band so that they can get through the game easier. And this really points to the fact that the players typically don't want the difficulty to go up or down. They want the challenges to change. Most people like particular types of challenges, like games might be more exploration-based, or they might be more dialogue-based, or they might be more discovery-based. Or there's a slew of different challenges in most games. And what players really want is different challenges, not more or less difficult challenges. And I think that using player modeling to determine what players like, which challenges they like, which they're good at, those are the things that maybe are better suited for a player modeling as opposed to difficulty adjustment. And by using the same model, you can build up a slew of archetypes of NPCs, if you will. And then the system can use those archetypes as buckets to determine which one is most closely associated with the player right now. Like, so if you have a game and you've decided that you've got, you've made archetypes of the slew of characters that can be in that game, of the play styles, I should say, of that game, then you can try to categorize the player's current style of play and say, oh, he's playing like a turtle in the game right now. And because of that, now I can somewhat predict how he's going to, what he's going to do in the future, and I can have the players respond to a turtling player as opposed to a generic player. And then later on, if I determine that he's no longer turtling, if I determine that he's now acting more like a rush player, let's say, then suddenly the AI can respond as to that style of play. And finally, answering number 3, the QA risks. This is kind of a big one because obviously this is something that's potentially not your call as an AI programmer. You have to be able to respond to this sort of stuff from management, but and it can not be completely in your control. However, AI should be getting involved in QA. Automated testing should be a thing. It should be something that you're doing, especially if you're doing a procedurally generated world. Having hordes of QA guys try every combination isn't really something that should be done if the amount of combinations is unbounded. You know, I mean, obviously that's where you're going to lead to problems because they just can't test everything in the amount of time necessary. Now, your super gifted QA guys are going to be able to target the problem areas faster so that you're not going to be having issues nearly as often as you would if you didn't have QA at all, but they're not going to be able to test everything, and there's always going to be super edge cases in procedural worlds that they're not going to find. But automated testing obviously gives you an untiring army of people that can work around the clock to try and find those edge cases. You can set up AI-controlled players to try everything and just let them go for the weekend or the week or however long it takes. This is essentially the equivalent of unit testing in software, and this is a completely ubiquitous thing in software engineering companies, but yet we don't do it with our gameplay systems as often as I think we should. Secondly, I think that this is what I was talking about before, when players are given more power to control what's going on, to try new stuff, I think that they're much more tolerant to having things go a little bit awry. In fact, I would go so far as to say that some of the most memorable moments in procedural sort of sandbox games are when things go a little bit awry. It's been years and years since the bug happened in World of Warcraft that caused equivalents of a virus to be spread across the entire continent. But people still talk about that, like, oh, I was there that day, it was hilarious, I died, ha, it was great. It killed everyone. And those sorts of things are not seen as a horrible affront to the game. Because they happen because of player interaction, they're almost seen as somewhat exciting and cool, and they're kind of a part of being in that community, as opposed to being something that we need to completely stave off. But you do need to do some sort of shoring up of your AI system, because if the system is such that, you know, if you're just going to give them like a Lua a Lua processor and let them script anything out that they want, you know, you're going to end up having security issues. Or if there are ways to hack the system, and you've got downloadable content, you know, microtransaction sort of stuff, you might be losing money, that kind of thing. You are going to have to watch your AI systems so that they don't become a security hack point, a weak point. And those sorts of things are just something you need to pay attention to. So that, I mean, I don't think too many games are just releasing huge, you know, whole scripting engines to the community. And even if they are, they're typically not, you know, given free rein. You know, that these things are put in a sandbox so that they can crash nothing, right? They can't crash the server. They can't hack the server. And you just have to make sure that you're setting your system up so that it's not a security weakness. But also you need to like build in gameplay hooks to shut down exploits. So not only should they not be a security weakness, but they shouldn't be a gameplay weakness. Some things might be going on out there, like if a gold hack is found where you can suddenly dupe a bunch of gold, it might throw the entire economy out of balance. And so you should watch for things like a velocity sort of measure on a particular stat, and have gatekeepers so that, yes, you allow freedom of choice and freedom of movement, and the AI system should be able to handle it. But if something goes out of control, you need to be able to stop it before things go nutty. And again, don't rely on software engineering friendliness. The system is meant to be flexible and meant to be procedural. So instead, handle bad inputs. Don't assert. I gave a talk on this as well at GDC. I don't know how many years ago, but don't assert on things. Don't assume that your inputs are good. Assume that they're bad, actually, and be able to handle that gracefully. And you shouldn't have as many problems as you would expect, even when things can go kind of wonky. So I kind of want to sum up and then take questions. Procedural AI in games can work. You just have a lot of things that you need to sort of ensure. There's a lot more setup. However, this can lead to reusable AI. You can end up having a suite of characters that you could potentially reuse in another game later, just by using the same mental models abstraction for the final game. And you need to build your agents and the game with systems in mind by using that abstraction layer. Use NPC models with your players so that you can not only personalize their content, but you can more readily respond to player changes of player behavior by being able to kind of identify that player behavior. And watch out for security concerns, but of course the whole point of having procedural games is to provide more of a toy as opposed to a highly crafted game. And so if you relax a bit, you can actually let your players play and really enjoy the game. And so that's the presentation. Thank you. Any questions? Oh, okay. I'm using the mic. Yeah, sure. um, answering number 2, sure. Can everybody still see the screen? I'm assuming you can. The question here I see is, so do designers have to come up with the player archetypes? And I would say that's a good way to start. Usually you can come up with a large swath of archetypes that end up being a good sample or even good coverage on the state space of your game. And then after time, you can also be analyzing players, and if they don't really fit into one of the archetypes, you can potentially have found a new archetype, and then you can add that into your chunk of game. You know, you might even end up making new characters down the road that you didn't think of before. And the jury's seconded with the ones that are used for the NPCs and for the player. Yeah, exactly. So when I say archetypes, you know, I mean, like, let's say in an RTS game you have a turtler who's going to build up his tech defenses, his tech tree until he attacks, versus a rusher who's going to build up a powerful unit as quickly as possible and then just rush you with it as quickly as he can. Those are archetypes that, yeah, the designers would come up with and not only incorporate into the game AI itself, but be able to use as identification on the player. Misty, the subject came up recently of a chatbot passing the Turing test. What are your thoughts about the Turing test itself and the future potential for computers to genuinely trick humans? I think computers genuinely trick humans all the time. The Turing test is an interesting test in that because it's sort of like No Child Left Behind, right? You end up solving for the test as opposed to solving for the concept of the test, which is that you want something that's intelligent enough that computers sort of trick humans in that humans can't tell the difference. But in reality, what Turing test sort of chatbots end up doing is solving for the Turing test, right? So they specifically type slower than a computer would, and they use spelling mistakes and those sorts of issues. And so, like, I think that the Turing test is a fun metric, but personally I think a better metric would be a Turing test of games, which is like, can you tell if you're playing against a human or not, as opposed to a specific Turing test involving language and typing and all of that stuff. I think that if you're playing League of Legends and you can't tell if you're against a bot or a team of people, that's a better Turing test as far as I'm concerned. Jury says, I assume you would maybe use some sort of statistical clustering. Definitely. I mean, we actually did some clustering work at Blizzard on achievements, which people were solving which achievements to try and figure out what styles of play they had as far as WoW players was concerned. And statistical clustering was what they used. And so, yeah, that's really, it's a very easy thing to do if you have the data, and it's a very powerful tool. Referring to player modeling, yeah, exactly. I mean, player modeling, that would be how you would bucket them, right? But it would also potentially be how you find new archetypes of plays through statistical modeling. Like, oh, this is outside of the range of comfort as far as the current buckets. Maybe we found a new bucket. Anybody else have any questions? All right, well, very cool. Thank you all for coming, and I'll talk to you soon.